Good evening, everybody. I wanted to take some time and talk about what I think is the biggest evolution that we have in 3D printing since a long time, and that is Input Shaper. And what is Input Shaper is a technology that runs under Clipper that will counter the vibration of the printer, the thing that causes ringing or ghosting on the printed parts, and will counter that and not sacrifice print quality, even though you're going lightning fast. Because that's my goal with this printer, is to be able to print faster, better, without sacrificing quality. So I've been able to achieve that with Input Shaper. Well, let's talk about what is causing ringing first. We need to understand that this is caused by printer vibration with sudden acceleration of anything that is a mass. When you move a mass from A to B with a certain energy, it will generate vibrations. It will generate energy, basically, and that will translate to vibration. So the first thing that you need to do to avoid vibration, without even going into tuning Input Shaper, is try to remove weight on your printer. Anything that is in movement, in this case this is a Core XY, so everything that moves needs to be as light as possible. In my case, I've went with the lightest, tiniest extruder that I think is on the market right now. I know there's a couple others, but this is the Hextruder made by the guy that makes the Hevor. His name is Olivier, and it's really tiny, really small. So I've also removed the weight by removing the aluminum extrusion on the x-axis, going with a carbon fiber square tube. I've done everything I could in the design of this printer to make it light. So small carry edge on both sides. Everything is there. So the next thing is frame rigidity. If it vibrates, if the frame is rigid enough, then it can take a lot of vibration before having some ghosting or resonance, or what you call ringing. So make sure your frame is as rigid as possible. Add braces. I've added some at the bottom here. So in this printer, all the acrylic panels, the aluminum panels at the bottom and in the back, they act as brace, making the printer super stiff. It will not move, not shake anymore. I've also added wall anchors. This is holding the printer on the x-axis, and there's a big one at the bottom. At the rear of the printer on the y-axis that will hold the printer steady. So the printer is super stiff. I've also made sure that the bed is rigid enough. I'm using 10 millimeters smooth rods on each side, and it was still not enough. I know maybe one day I'll go with linear rails. They are better, but for now I'm still running 10 millimeter rods. Still better than 8 millimeters. They're stiffer. But I've also just recently added palm wheels, or I don't know the name of those wheels. They're I think that's what you call them, palm wheels. And this has added a lot of stability to the bed, because when it was moving fast, the frame was rigid enough, but the bed was kind of having vibration caused by the print head. So now that have added these palm wheels, it's adding another layer of stability to the bed. So frame rigidity and weight or mass, this is what you need to take care of first. And then once you're completely sure that you have done all your possible to make it lighter, then you can think about tuning Input Shaper. And then you can go fast, print very fast without any ringing. So there's another thing. Once you've done the installation of Input Shaper, I'll show you what I mean, but belt tension is also something really critical here. And I've just learned that today. I mean, I knew it before, but now that we have a tool to measure it with the accelerometer sensor, I've been able to tune my belt with the accelerometer sensor, and I'm going to show you that. I've learned something really cool about belts and how they can help or make some more vibrations to your printer. So there's a right tension that you need to go with belts to avoid transmitting vibration from motors to the frame and stuff like that. So we'll go over the process of what you need to make input shaper. There's two ways. I'm not going to talk about the first way. There's an article about it. Basically, it's a manual tune where you print something, a part with some cracks on it, and you'll see at what frequency it starts to go away, or I don't have that whole technique, but it's well written on the Clipper site. We're more interested in tuning it automatically and avoid all that stuff with a small sensor that you install on the print head. And in my case, you'll see the sensor right here. It's an ADXL345. It's a gyroscope or accelerometer. It calculates, it knows basically how it moves, how it accelerates, and it can measure vibrations with that. So we're going to show you how to install that, make it work, take some measurements, and once you have that installed, I'll show you how to tune your belt the way I do. I don't know if it's the best way. I've done a lot of intensive testing with that, up to a point where I thought I had damaged my motors, but no, apparently I was just stupid enough to make a mistake in my firmware. Instead of putting 6,000 in acceleration, I've put 60,000. Then I was wondering why all of a sudden my printer was making some weird noise and weird stuff. So we're gonna go right now into the details. What you need to buy. Well, obviously you need to buy that sensor. I'll put a link in the description where I got mine on Amazon, so you can get one. And we're gonna go directly on the computer and I'll show you how to set it up. Okay, so to install, well, first of all, let's talk about the sensor itself. So I got mine on Amazon, and this is what it looks like. It's an ADXL345, and just be careful on the version that you get. It doesn't really matter, but just be careful on the pinout. The ground and the VCC might be on the opposite. I mean, the VCC first, then the ground, so just be careful with that. Just a heads up there. And then you'll also need to solder all those pins to the board. So you need a soldering station and soldering skills, which is not really difficult. There's a lot of videos on the web that you can get, you can see to know how to solder that. Pretty easy to do. So get that one, ADXL345. I'll put a link in the description, as mentioned, where I got mine. It's on Amazon.ca because I'm Canadian. So this is the sensor you will need. Once you have that, I'll take into consideration that you already have Clipper installed, that you know what Clipper is and you're familiar with that already, because I'm not going to go through all the steps to install Clipper, but I'm going to go into steps for the accelerometer installation. So I'll also put this link in the description as well. So with the ADXL345 accelerometer, you'll be able to measure resonance, and with input shaper, it's going to compensate for that resonance. The article here is really what you need. It will show you the pinouts and where to connect that on your Raspberry Pi. Really easy to do. Just make sure you follow that diagram very carefully. In my case here, I'm going to give you a little tip of what I've done it, of how I've done it. If you take a look at how they do it on the screen here, it's going to take the 3 volts on the first pin of the GPIO and the ground on the third one on the right side. Then all the other pins are at the bottom. But if you look at the pinout of the GPIO, you'll see there's a 3 volts and a ground right next to those pins. So in my case, I've just, and I'm going to show you that here. In my case, I've just done a 8-pin connectors. This is DuPont connector, or DuPont, I don't know how to pronounce that, but this is the connector I've made. And it's going to use all the pins that are close together, so that way a 8-pin connector like that can fit directly there on the Raspberry Pi, so you don't have to go with individual pin and try to plug them in. It's just one big connector, and it is a lot easier to do it that way, I think. So in my case, I've used, I know it's ghetto, but I've used what I had in hand, which is an Cat5e cable. It's one wire. It's not multiple strain or multiple wires inside each individual little wires. It's one big copper wire, and it's also twisted, so it helps with the noise, because that sensor, let me tell you, it's super fragile. Not fragile in a way that it will break, but it will catch any electric noise. So it needs to be precise. So that's why I've chosen to use that cable. There probably is better cable, better choice out there. That's what I had in end, because I'm a network guy and I have network cables laying around. So this is how I've done mine. So again, be careful on the polarity for the plus and the ground, and you'll be able to connect that to the Raspberry Pi very easily. So now that you've done the connectors, the wires, and you need to mount the accelerometer to your printer. In my case, I've mounted it on the print head at the best place I think it could be mounted for my setup, at least. I'll show you that in a moment. Do I have a picture of that real close? Well, I'll show you that later. So there's a way to mount it. Basically, if you look at the sensor itself, the X, Y, and Z, it's showing on the sensor itself. So mount it properly to your need. If you have a bad swinger, it's still possible to do that, but obviously the X and the Y are in different position. I mean, in different physical moving hardware. So you'll need to first mount it. To measure the X, you'll need to mount to the print head. Then you'll need also to repeat that for the Y and find a way to mount that sensor on your bed to measure the vibration on the Y. So it's going to be in 2 different steps. If you have a bed swinger like a Prusa, Corex Y, you just measure it from the print head. So once you have mounted the sensor, just connect it, and then you need to connect to your printer. I'm using PuTTY, but any SSH terminal can be good as well. And really, the article is going to tell you step by step what you need to run for the installation. So they've done a really good job there. I'm not going to do that now because obviously it's already done on my Raspberry Pi, but these are the commands you'll need to run, that one and that one. So it's going to install everything you need. And then after that, what you need to do is to modify your printer configuration, your clipper configuration, and you need to add those lines. If you have not yet installed the clipper MCU on your Raspberry Pi, you will need to do that. We can do this now. There's an article here that you can follow, but real quick, what you do is basically the same way as you install Clipper. Instead of selecting your board, you're going to select the Linux MCU and follow the instructions. I don't think I'm going to do that right now. Well, I can. Well, it's just going to take a moment. So the steps are there. We're just going to go into the Clipper folder, and then we're just going to make the menu config, And then, as I said, we're just going to need to select the Linux process instead of the board that you will normally do to install Clipper on your board. So you select Linux process, and that's about it. You escape, and it's going to save. Since there's no change on my side, there's no need to save. And then you stop Clipper with this. You stop the service. You type in make flash, and then sudo service Clipper start. You're going to restart that. And what it's going to do, it's going to install Clipper software onto the Raspberry Pi, so that the Raspberry Pi now becomes another MCU, or call it another printer board. You can use that Raspberry Pi as a secondary printer board, and that is what you're going to need to get access to that little accelerometer. So that is it for now. Now that you've installed the MCU onto your Raspberry Pi, you need to add this to your Clipper config. This guy here, the name here, it can be whatever you like to be. It could be Raspberry, it could be whatever you like. It's just the name. As long as you use that, if you define any other pins for Clipper, just reuse that that guy here. So let's see on my side the config. So I have my, this is my SKR 1.4. This is my Raspberry Pi. And as you can see, it's using /tmp Clipper host MCU. So this will direct you to the Raspberry Pi. And then you need to add this line as well to define the sensor. And also you need to add this into the print configuration. It's all well detailed in here. And this is the coordinate of where you need to go. It really needs to be in the middle of your print bed, and it's also advised here. So in my case, since I have a 310 by 310, it's going to be 155X and 155Y. And then it's all good. I mean, you restart Clipper, make sure that everything is working, and then there is a command that you can use to test if you're able to communicate with that sensor. And the command that you need to run is accelerometer query. So it's going to query the accelerometer for you. Let's do that real quick. Yeah, sorry. My connector is not plugged in. So just bear with me. I'll go connect that and get back to you. Hold on. So this is the cable I've made for it, and we just need to connect it on the sensor like so. And now we are ready to run the test and start measuring vibration. So I like to do my measurement in a way that it's like when the printer is printing. So I've made the cable go through that hole, and I can measure while the cover, the top lid, is closed, because that can impact also measurement. So everything counts. So do the same thing if you have a top cover, close it. Just make it so that it's like when you print something. Okay, so we have connected the sensor, and like I said, we need to make sure that we are able to communicate with the sensor. So we're just going to run this little command here. This is main cell, but it can be fluid, it can be octoprint. You just send this as if it was a G code. So accelerometer query, and it should return some values. So as you can see in this case, these are the values that are sending back to the Raspberry Pi. I don't know how to interpret that, but we get some values, so that's what we need. If you don't get anything, check your wires, check your connector, check everything. So we've done the query. So now I think we're all done. The only thing that needs to be set is the max acceleration and max deceleration on your printer. it needs to be set to 10,000 because it's going to go really, really quick, really fast. So you need to set that. In my case, it's done already here. I normally run a bit higher than that, but for the test, I'll leave it to what it's asking. So 10,000 and 10,000. And then you are ready to proceed. So you can test each axis individually. The command that you'll use is test resonance axis and then X and then the Y. Or you can, I think it's called, there's a command, where is it? There's a command that will do both for you, shaper calibrate. It's going to run X and then Y, and it's going to do the calculation, everything all at once. But I prefer to do it manually, so we are going to do this. Copy, and I'm going to paste that. Well, first of all, it needs to home, so otherwise you'll get an error saying it needs to home first. And we're going to run it. I'm not sure I want to film that. It's no point, but what you'll hear and what you'll see, the printer will go to the middle of the bed and it will slowly start to vibrate. In fact, I'll just run it and you'll see what it does. So we're not going to be able to listen because the printer is on a different room, but it will. You will hear the sound will go like higher and higher and higher. It will go, and you'll see. I think all the way up to 130 hertz. So this is what it's going to do. It's doing the X first. So you'll see the print head starts to move, and as it start really low, like 0 hertz, and then it will ramp up to 130 hertz. So yeah, and the higher it goes, at some point you're not going to be able to see the print head moving. It's going to go too fast, but you're going to hear the sound. Trust me, it's really, really, it's really funny the first time you do it, but then you get used to it. So it will ramp up all the way to 130. So I'm just going to go ahead and fast forward all the way until 130. Okay, and we are done. I was wrong. It's going all the way up to 133 hertz. And what it's going to tell you, it's going to tell you that it's written some data to /tmp resonances x blah blah blah. It's going to create a CSV file, and now you need to run a command to interpret and to transfer that CSV file into a graph. And the command can be found on the same article here. We've done this, and then these are the two commands. There's one for X, one for Y. So basically, we're just going to do X together, but you'll have to do the Y as well. So let's do the X, and we're going to run that command on the Raspberry Pi. And it's going to make some calculation, and it's going to suggest you a shaper. In this case, it's the EI shaper at 91 hertz. So it's also going to generate a PNG file, which is a picture file, on the /tmp resonance. So we're going to go with WinSCP. In my case, you can connect to your Raspberry Pi with any software you like that's going to do SSH. So we're going to go to TMP, and we're going to get that file here. So that's the picture, and that's the CSV file. We don't really need the CSV file. This is all the data that it has stored for you. So we're going to copy that. Let's just overwrite that one. Okay, so this is the kind of PNG file that you'll get out of this CSV data. I accidentally deleted the results that I got, so I'm going to use an older one that I've done yesterday. To interpret that, I'm really no specialist there. I'm no pro. I've just done a a lot of these tests recently just to understand what that does. And here it's going to tell you what to put in your printer configuration. So it's recommending you to use Shaper MZV. And if you look at the MZV data, it's MZV 79.6. So that's what you have to put in your printer configuration. I'll show you that in a moment. Mine has changed since yesterday. I've made other changes, and my results are here. So this is the input shaper part. It's also in the article there for Clipper, the one that we were reading. So you need to add this input shaper, and then on the X, shaper frequency X, you enter the data. In this case, it should have been 79.6, and the recommended shaper should have been MZV. But now it's recommending a different one because I've made some adjustment on the printer. So right now I'm doing EI at 93. And then on the Y, same thing, you'll run the test and you'll get a recommended shaper, and you'll take the frequency at which it's recommended. You're going to put that in your printer, your printer.cfg, upload that to the Raspberry Pi on your Clipper folder, and that's it. You'll be ready to run input shaper, and you'll see it's going to make tremendous improvement to your print quality. Okay, so what we are looking at now is my test that I've made with different belt tension. So on the left side, we go with the lower tension all the way up to the highest tension on the right. And once we analyze the data, it gets really interesting. By the way, I've called those files as 65, 120, 130, and 140. And this is the belt tension that I measure with my mobile phone with a spectrum analyzer. Basically, you just do like a guitar where you slam a chord and it will make a sound, and you measure that frequency. So that it's not super science. Every printer will get you different numbers, so don't take those numbers and put them on your printer. Longer path of the belt will make you lower frequency, smaller will go higher, and so on. So every printer is different, so don't use my numbers. This is just for reference. So on the left side, what I've noticed, I started at 65 hertz on tension, and I've noticed I was reaching 3.5. What I mean there is the vertical numbers are power spectral density. Basically, this is the force of the vibration, the amplitude of the vibration. So 3.5. But I was also noticing another kind of peak around 80 or 90. And then I cranked the tension up to 120 hertz. And the amplitude stayed the same around 3.5. And I still had that on that other peak there at 90, around 90. Then I cranked it up to 130. And to my surprise, I got rid of that other, or not completely, but I got rid of some of it, of that second peak. But at the same time, the amplitude of the vibration went up to 4. So I tested a bit tighter at 140 hertz, and then I completely got rid of the second peak. But at the same time, amplitude got up to 5. So maybe I got this completely wrong, but my understanding is that the higher tension you give to the belts, the more the belts will transfer vibration to the rest of the printer. And again, I may be completely wrong. I don't pretend knowing anything about these graphs. I'm just trying to understand with the test that I'm making. So if you understand this better than I do, please comment below. I would be very interested to learn. I've done many tests. My motors are really mad at me right now, but I've done this to understand what's going on with weights, with belt tensions, with everything, and trying to tune everything at the best as I could. So what I found best in this case was a a mix between, well, close to 130 hertz, where the amplitude doesn't go all the way up to 5, but also doesn't have a second peak somewhere. So I think I'm calibrated around 130, 35 something. So this has helped a lot on my side, and this is how I've tuned my belts. So next step is to test the actual input shaper now that it's activated on your printer. In this case, I've just downloaded this model from Thingiverse and sliced it to a speed of 200 millimeters per second. Don't go that fast if your printer is not able to do that. You need a hot end that will melt plastic fast enough. If you want to go to that speed, I recommend you the Nova hot end. But there are other good hot end out there if you want to use a Volcano, V6 Volcano, or if you want to use a Dragon with the high flow or the Mosquito high flow. I personally use the Nova hot end. I think it's an awesome hot end. So slice it to a high value if you can, and play with it. You'll see you'll get really good result. I'll show you my results that I've got from this slice in a moment. So from bottom to top, here are the results. The first one at the bottom is without input shaper and without wall mount. The second one from bottom is with wall mount without input shaper. The third one, we activated input shaper, but without any wall mount. And the top one, which the one that is looking the best without any ringing at all, is with input shaper and wall mounted. So that's it for tonight. Thank you for watching. I hope you enjoyed it. Sorry if it was a long video. I know I've put a lot of details. It might have been boring. Sorry about it. Hope now you can install Input Shaper, run it on your printer, and enjoy the no ringing printing now, and crank up the speed because now life is too short to print slow. Have a good night, everybody.